let's review a few examples of solving logs and exponents. So starting with the logs. To solve a log, I'm going to convert to an exponent. So the first one I have is log base 2 of x minus 2 equals 4. To get rid of or convert that log base 2, I'm going to use base 2 on both sides. So 2 to the log base 2 will cancel out, and I'll just be left with x minus 2. And on the other side, I'm going to grab my calculator and plug this in and see what is 2 to the 4th. Well, 2 to the 4th is 16. And now I still want to get x by itself, so I'm going to add 2 to get x equals 18. And now I can grab my calculator and plug back into the original function and do log base 2 of 18 minus 2, and I really do get 4 out when I plug back into this original function here. So I'm going to use 2 to convert log base 2. Same thing on the other side for letter C. I want to convert log base 9, so I'm going to use base 9 to get rid of log base 9 or convert it. Before I do, I have to condense this addition. So addition means multiplication. So I'm going to do log base 9, and I'm going to multiply together x minus 5 times x plus 3. I do have an entire Part A playlist to go back and review these concepts more in depth. This is just some quick review of some first part concepts. So I have x times x, which is x squared for my first term. My outer term, x times 3 is 3x. My inner term, negative 5 times x is negative 5x. And lastly, negative 5 times 3 is negative 15, and that equals 1. So I can combine some numbers here. I have log base 9 of x squared minus 2x minus 15 when I do 3x minus 5x. So now I am going to use base 9 to cancel out with that log base 9. So I'm going to do base 9 of both sides. 9 to log base 9 cancels. So that's going to give me x squared minus 2x minus 15 equals 9 to the first on the other side. 9 to the first is 9. And now I want to solve an x squared term. I'm going to bring this up here. To solve something that's an x squared, one side has to be 0. So I'm going to subtract 9 from both sides, which will give me x squared minus 2x minus 24 equals 0. Now I'm going to factor to solve. To multiply to be a negative 24, I must have a positive times the negative. I want to think of factors that differ by 2. So I could do 24 times 1, but that would differ by 23. 12 times 2 would multiply to be 24, but those differ by 10. 6 times 4 is 24, and 6 and 4 differ by 2. So I'm going to do positive 4 minus 6 to add up to be that negative 2. The bigger number must be the negative one. And I want to think of what makes each one of these factors 0. What makes x plus 4 equals 0 if x is negative 4? And x minus 6 equals 0. Add 6 to both sides if x is 6. And now we have to check these because they're logs. You can't do log of 0 or a negative. It has to be positive. So if I try to plug in negative 4 back to this original function, log base 9 of negative 4 minus 5, if you try to do log base 9 of negative 9 when you plug in that negative 4, it comes out to be an error. So I can't plug in that one, so this is not a real solution. If now we go and try to plug in 6, we would do log base 9 of 6 minus 5, which is 1. So log base 9 of 1 plus log base 9 of 6 plus 3, which is log base 9 of 9. We get out 1 on the other side. So one of our solutions work, the other one does not, because it makes us take the log of a negative, which is not going to work. Our calculator is going to give us an error. So that's reviewing a couple log examples. Let's switch gears and use logs to solve exponents. So for the next two, I'm solving for x up in the exponent. So first I want to get that exponent on one side by itself. So right now it's multiplied with 10. I'm going to divide both sides by 10. So that I have 5 to the x by itself. And on the other side, 180 divided by 10 is going to give me 18. Now to solve for x stuck up in the exponent, I'm going to use logs. So log base 5 and 5 will cancel out. So I'm going to do log base 5 of both sides. They cancel each other out on that side, so I bring down that x is log base 5 of 18. It doesn't say we have to round any place, so I'm just going to leave it in exact form, just like that. And I could plug back in for x into the original function. 10 times 5 to the log base 5 of 18 really does come out to be 180. Let's do that same thing with this base e. We're solving for x up in the exponent. So first thing I need to do is get that exponent on one side by itself. So I'm going to take 13.5 and subtract that 8 over to the other side to try to get x a little bit closer to being by itself. So 13.5 minus 8 is going to give me 5.5 on that side. So I'm going to have e to the x minus 2 equals 5.5. I might leave a little bit of space again to convert to a log. So now I want to convert base e. So when I converted log base 5, converted base 5, I used log base 5. If I wanted to have 2 to the x, I would use log base 2. If I had 13 to the x, I'd use log base 13. So to get rid of or convert that base e, I need to use log base e, which is shortened. It's ln is log base e. And that brings down that x minus 2 is going to be ln in parentheses 5.5. And then to get x by itself, I'm going to add 2. So x is ln of 5.5, close your parentheses, plus 2, there's our exact answer. And we could definitely plug this back in for x and see that we really do get 13.5 out on the other side. So there's just a couple examples of solving logs and exponents. If you need more, check out Part A playlist to go over those algebra examples, solving more logs and exponents. There's lots more videos on my channel.